Okey kelas, Assalamualaikum warahmatullahi wabarakatuh dan selamat tengah hari. Okay, so dalam video sebelum ni saya dah buat sedikit introduction berkenaan dengan higher order linear differential equation, di mana higher order linear differential equation ini melibatkan differential equation yang mempunyai order lebih daripada satu. So kalau sebelum ni kita fokus on first order dy dx, now we have more than order 1 differential equation bermula dengan order 2. Okay, di mana order of differential equation ini adalah berapa bilangan kali kita differentiate kita punya equations. So you will come out with a few numbers of derivative. For example, if you have the second order, awak akan ada d square y dx square. So this one represent the order of your differential equation. So now we are moving to learn on the higher order differential equation, di mana higher order differential equation ada dalam general form yang berbentuk A n x d n y dxn plus a n minus 1 x d n minus 1 y dx n minus 1 until you have a n dy dx, a not dy 1 dy dx plus with a not y equal to 0. Okay, di mana a di kat depan ini adalah constant, any constant. Okay, any constant. Dan kalau awak tengok awak punya higher derivative ada derivative of power of order n, lepas tu derivative of order n minus 1, sampailah awak ada the first derivative dy dx and the dependent variable itself. Okay, for example, if we have 4d cube y dx cube plus 2x d square y dx square plus with 2 dy over dx plus with 3y equal to 0. This one is the higher order linear differential equation. Okay, and the higher order is because we now have the order of differential equation more than one. Kalau sebelum ni kita hanya tengok yang dekat sini sahaja. And then dalam video itu juga saya dah ajar macam mana kita nak tentukan sama ada the higher order derivative ini, differential equation ini adalah homogeneous ataupun tidak. Kita tengok kepada sebelah kanan. Okay, kalau kita punya gx equal to 0, means this one is the homogeneous linear differential equation. Okay, dan awak kena pastikan di sebelah kiri ini hanya melibatkan dependent variable dan dia punya derivative sahaja. Okay, contohnya kalau kita ada equation, saya bagi contohnya, kalau kita ada differential equation 3x d square y dx square plus 4 dy dx minus 3y plus 3 equal to 0. This one is non-homogeneous. You need to be careful. Why? Because on the left side, we only need to have the dependent variable and its derivative only. Okay, the one that don't have any dependent variable and its derivative must be on the right. Therefore, you should write your differential equation in the form of 3x d square y dx square plus 4 dy over dx minus 3y equal to 3. And because of on the right side is not equal to 0, means this one is the non-homogeneous differential equation. Is different. The definition of homogeneity is different with the first order differential equation. Okay, and then from that, saya nak, okay. So we know that our differential equation has the solutions. When we are talking about solution of our differential equations, okay, when we are talking about solution of the solution of our differential equations, Okay, the solution will be in the term of dependent variable. For example, kalau sebelum ni kita ada dy dx first order. Okay, bila kita cari solution, sama ada kita guna separable equation atau kita guna linear method yang kita belajar sebelum ni, at the end what we will get in return is the function of y in term of the independent variable. Kalau dia punya dependent variable y, independent variable dia x, so kita akan dapatlah equation of y in term of x. Kalau kita ada dz over dt, so kalau kita solve, kita akan dapatlah z in term of t. So this one is called as a solution. And if you have the first order differential equation, order 1, you only have one solution. When you have second order differential equation, you will have two solutions. When you have third order differential equation, you will have 3 solutions. Okay, it's similar with the linear equation that we learned in basic maths. Okay, if you have linear equation, 4x plus 3, you will have only one solution, x. If you have the quadratic equation, x squared to the power of 2, you will have x1 and x2, 2 solutions. If you have x cubed, you will have x1, x2 and x3 as the solution. So same goes to the concept of linear differential equations. Okay, if you have the first order differential equation, you only have one solution. If you have second order differential equation, you will have 2 solutions, and so on and so forth. Okay, so now we are talking about higher order differential equation, where our higher order differential equation has either homogeneous equation, okay, homogeneous equation or non-homogeneous equation. Okay, so how to determine whether our differential equation is homogeneous or non-homogeneous? If the function of gx on the right side, okay, the function of gx on the right side of our differential equation equal to 0, therefore the equation is homogeneous. If the gx is not equal to 0, the differential equation is non-homogeneous. Okay, and then we also learned on the previous video, we have the 2 types of solution of homogeneous differential equation. Now we are focusing on homogeneous. Okay, so for the solution of homogeneous differential equation, we have either the solution is linearly dependent solution or linearly independent solution. Why we have linearly dependent or linearly independent? Because now we are talking about higher order differential equation. Means that we will have more than one solution. It's either 2 solution y1, y2, or 3 solution y1, y2, y3, or 4 solution y1, y2, y3, y4, or 5, 6, 7 and many more solutions according to the order of differential equation. Therefore, we need to know that either the solution is dependent or independent of the other solution. So how to determine whether our solution is dependent or independent by using the Wronskian value, di mana Wronskian value adalah determinant of the matrix. Macam mana kita dapat matrix ini? Dia depends kepada kita punya order. Kalau order kita punya differential equation adalah 2, kita akan dapat matrix 2 kali 2. Kalau kita punya order matrix order kita punya differential equation 3, kita akan dapat 3 kali 3. Macam mana kita nak bentuk matrix untuk Wronskian value? Kita letak semua solution. Okay, kemudian kita akan differentiate kita punya solution. Macam mana kita nak tahu nak differentiate berapa kali? n-1 kali. Kalau kita punya order 2, kita differentiate sekali sahaja. Okay, maksudnya kalau kita punya order 2, okay, yang ini adalah solution pertama, solution kedua, differentiate sekali sahaja. So awak dapat 2 kali 2. Tetapi kalau kita ada order 3, kita akan differentiate 3 minus 1 kali. 3 minus 1 is equal to 2. Kita akan differentiate 2 kali. That's why you will get the 3 times 3 matrix. Ini solution pertama, solution kedua, solution ketiga, differentiate sekali, differentiate kali kedua. Differentiate sekali, differentiate kali kedua. Differentiate sekali, differentiate kali kedua. That's why you come out with the matrix 3 times 3. And what is the Wronskian value? The Wronskian value, you need to find the determinant of that matrix. Okay, so if the value of Wronskian is equal to 0 means that your solution is linearly dependent. Okay. Otherwise, if your W, the Wronskian value, is not equal to 0 means that your solution is linearly independent. So that is how we want to determine whether our solution is dependent or independent. All of this have been explained in the previous video. So please watch the video. Okay, I want to try one question come from the past year question about the linearly dependent and independent solution of our differential equations. Okay, so it's come from the past year. It is come from the past year July 2017. You can check. Okay, past year July 2017, where the solution, the question is given a differential. Mind my writings. Okay, I want to be quick. Given a differential equation x square d square y dx square plus x dy over dx minus y equal to 0, where x is not equal to 0. Okay, if the solution to the differential equation are y1 equal to 1 over x and y2 equal to x, determine whether y1 and y2 are linearly independent. Okay, soalan bagi, dia kata given a differential equation, dia bagi differential equation, this one is the differential equation, and then dia bagi kita solution. Okay, di mana solution untuk differential equation itu y1 equal to 1 over x and y2 equal to x. Sekarang dia suruh kita tentukan sama ada y1 dengan y2 ni linearly independent ke linearly dependent. So when we want to determine whether the solution is linearly dependent or independent, we need to find the Wronskian value. Where to find the Wronskian value, we need to find the determinant of the matrix. What is the size of the matrix? It depends on the order of your differential equation. Now your differential equation is order 2, means you have 2 times 2 matrix. So what you need to do is you need to write the first solution, which is 1 over x, and the second solution, which is x. And then you need to differentiate how many times? The order minus 1. So the order is 2 minus 1 is 1. So means that you need to differentiate once only. So differentiate 1 over x, you will get negative 1 over x to the power of 2. You need to find out how. Okay, because 1 over x is actually x to the power of negative 1. So when I want to differentiate, okay, negative x, negative 2. So I bring it down, so it will be negative 1 over x to the power of 2. And differentiate x is equal to 1. So now you need to find what is the determinant of 2 times 2 matrix is by using the formula AD minus BC, multiply this one, 1 over x minus with multiply this one. Okay, so x multiplied by negative 1 over x square. So what you will get is 1 over x minus is plus. This one can be cancel out. So you have 1 over x plus 1 over x is equal to 2 over x. Means that the value of Wronskian is 2 over x, which is not equal to 0. So when your Wronskian value is not equal to 0, therefore your solution y1 and y2 are linearly independent solution. This is how you want to determine whether the solution is linearly dependent or linearly independent. Okay class, so we know already how to find out our either our solution of differential equation linearly dependent or linearly independent. So now we want to see the definition of fundamental set of solution. What is the definition of fundamental set of solution? It said that any set y1, y2, yn, where y1, y2, yn ini adalah solution kepada kita punya differential equation of n linearly independent solution of the homogeneous linear. Okay, sekarang kita fokus kepada homogeneous equation. okay, on an interval I is said to be fundamental set of solution on the interval. Maksudnya, kita ada higher order differential equation. So higher order differential equation ni dia boleh jadi either homogeneous or non-homogeneous. So now kita fokus kepada homogeneous dulu. So homogeneous ini ada solution sama ada linearly dependent solution ataupun linearly independent solution. Okay, so solution yang linearly independent kita panggil dia sebagai fundamental set of solution. Okay, solution yang linearly independent kita panggil dia fundamental set of solution. Katakanlah kita ada 3 solution Y1, Y2 dan Y3. Bila kita check Wronskian value is not equal to 0 means our solution is linearly independent. So this solution is called as a fundamental set of solution. Itu je. Okay, maksudnya kalau kita ada solution yang sifatnya linearly independent, that solution we call as a fundamental set of solution. Okay, so let's see this definition. Let Y1, Y2, Yn be a fundamental set of solution. So now we already have a fundamental set of solution. Okay, for the homogeneous differential equation, then the general solution of the equation can be written in the form of this one. So sekarang ni saya ulang balik semula penceritaan kita ni nak bagi awak nampak. Sekarang ni we are talking about homogeneous higher order differential equation. Higher order differential equation ada 2 jenis, sama ada dia homogeneous atau dia non-homogeneous. Macam mana nak tentukan dia homogeneous ataupun non-homogeneous? Kalau homogeneous gx equal to 0, kalau non-homogeneous gx is not equal to 0. Gx tu dekat mana? Gx tu dekat sebelah kanan awak punya differential equation ni. Okay, so bila kita dah tahu homogeneous dengan homogeneous, kita tahu yang kita punya differential equation akan ada set of solution because dia higher order. So dia akan ada sama ada 2, 3, 4, 5, 6 ataupun selebihnya solution mengikut bilangan order. Okay, so kita punya homogeneous solution ni dia boleh jadi sama ada dia linearly dependent ataupun linearly independent. Macam mana nak tahu kita punya solution ni linearly dependent ke linearly independent? Dia depends kepada Wronskian value. Kalau Wronskian value is equal to 0 is linearly dependent solution. Kalau Wronskian value is not equal to 0 means that we have linearly independent solution. Okay, so the set of solution yang linearly independent ini kita panggil dia sebagai fundamental set of solution. Okay, maksudnya katakanlah kita ada 3 solution Y1, Y2 dan Y3. So Y1, Y2 dan Y3 ni kita panggil kesemuanya adalah fundamental set of solution. Dan fundamental set of solution ini can be written in a general form sebagai general solution. Macam mana nak tulis dia sebagai general solution? Kita boleh tulis dia Y equal to C1 Y1X plus C2 Y2X plus C3 Y3X. Ini adalah superposition principle yang kita belajar sebelum ni. Maksudnya, ketiga-tiga solution yang linearly independent ni kita boleh gabungkan dia. Okay, kita boleh gabungkan dia Y1 tambah Y2 tambah Y3 dan setiap solution ini boleh didarabkan dengan any constant C1, C2 dan C3. Dan keseluruhan ini pun kita panggil dia sebagai general solution of our homogeneous differential equation. So kalau kita nak solution, kita just combine all the solution is according to the superposition principle yang saya dah explain dalam video sebelum ini. Okay?